Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and this is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we talking about today?
Hi Michael, today we are going to talk about monitoring, and I think we are touching very wide fields, wide areas of Postgres, and probably we will revisit each one of them, trying to go deeper in some specific sub areas, right? But monitoring is huge. Like every project should have it, right?
Well, do you mean so? Let's check that first. So we're naturally for large enterprises, we definitely want monitoring. We definitely want database specific.
Sometimes couple of tools. So sometimes I saw big projects using 3 monitoring, and all 3 tools were monitoring Postgres. Because none of them were perfect to be enough alone, right? So we needed to combine parts from 3 places. It happens, I think. But by the way, it's not a problem if you have a couple of tools used, if you know that overhead is low, right? So we are talking about Postgres monitoring. This is a huge topic. And my main statement is there is no good product developed yet.
Perfect product, maybe?
Good is maybe no great products. I don't see great products because I understand what should be present in any Postgres monitoring, and it's not my point of view. We a couple of years ago we started some community work, so we started to discuss various tools. We had several sessions in Russian community. We had several sessions reviewing various tools, both open source and commercial, and then we created a document called monitoring checklist, Postgres monitoring checklist, collecting ideas what should be present in monitoring and what should be must have or like nice to have and so on. And then some people outside of Russian community joined as well, and eventually I think we've got very good understanding what should be present, like 100% if you want your monitoring to be very useful. And I don't see, like, if we take any product, commercial or open source, or maybe even in-house. Sometimes in-house products I see very good ones, like very great parts, but none of them meet these criteria, like even 80%. Usually it's below 50.
So we're talking about things that you consider probably almost a must-have for most projects that people care about the uptime of. Making sure they have each of those covered in, is it monitoring and alerts? Do you count that as the same thing?
So, alerts, it's like a slightly different topic. I'm talking about troubleshooting sessions when we open monitoring and try to understand what's happening, what's wrong, because we have some complaints from users or from our coworkers, and something wrong with Postgres happening, and we need to understand what exactly is wrong. And I see 2 big areas which must present in any monitoring. First area is, of course, we should have physical metrics like CPU, memory, disk I/O, network. It should be covered, and almost always it's covered, and it's separate. But Postgres specifics, and here we can recall Alexey Lisovsky's pgstats.dev, this interactive picture which shows you architecture of Postgres and what system views and extensions or tools are responsible for monitoring particular part of Postgres architecture. It's a great tool. We will provide link in description, I'm sure. So this should be present in monitoring, and this first part I call dashboard number 1. The goal of dashboard number 1 is you have like 30 or maximum 60 seconds, and you need to perform very wide and very shallow overview of all Postgres components, all Postgres areas and understand which area looks not well. So we need to go deeper using other dashboards probably, or maybe manually looking at Postgres and so on. And second component is query monitoring. Query monitoring is like, it's like not a king, it's a queen of observability, right? It should be present always. It's a whole different topic. It should be present in any monitoring. And again, I don't see all, like some systems improving. For example, Datadog currently is very well improving in this area particularly. And by the way, they do it for all databases, not only for Postgres. I just see how well they are compared to 2 years ago. But they have big mistakes as well. Like not mistakes, but disadvantages, like missing parts, which don't allow me to work with it. But probably we should postpone a discussion about query analysis. It's like maybe different talk. But let's focus on this first, like wide and shallow dashboard. Like I want everything quickly, half of each component.
So the use case is my page has just gone off, or I've got a notification, or a user's mentioned something that doesn't sound good, and I want to look at something and see where is the problem. Like where do I even start looking? Right.
So either some people say there are errors related to Postgres or some performance degradation.
Great.
I hear some sound. Like dun, 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 dun. Okay, sorry. Probably
okay.
Right. So and we want like to have 10 or like dozen of like 12 metrics present on a single dashboard, so we quickly understand are we okay compared to like 1 hour ago or 1 day ago or 1 week ago, or we are not okay in particular areas. So let's dive deeper. So let's probably quickly have some overview of these metrics, because I have a list, and we can attach this list to our episode, right?
Yep.
Yeah, let's start.
So what's top? What's the top of your list?
At the top of the list is two major things which represent behavior of any multi-user system: throughput and latency. Like not only multi-user, but where network is also involved. So throughput and latency. Throughput, if we talk about databases, Postgres particularly, can be measured in several ways, but two ways are most interesting to us. It's TPS and QPS, transactions per second and queries per second. And unfortunately, Postgres doesn't allow you to measure the second one really well. TPS are present in PG star database or PG database. I always mix it. Exact commit and exact rollback. We observe these two numbers, and some of them, how fast it's increasing. This is our TPS. So
or decreasing, right? If there's some problems,
cannot decrease. It's accumulative. So
sorry.
Right. It's just a counter of committed transactions and rolled back transactions. And
sorry, I thought you were talking about TPS still. Yeah.
And so, right, what can decrease if we divide it by the duration of, like we need two snapshots as always, right? And we need to understand how many seconds between them, so we divide. And of course, this like speed can go up and down. TPS can go up and down. But QPS, unfortunately, Postgres system views don't provide it. And usual trick is to use PGStar statements, but it's not exact number, unfortunately, because PGStar statements, as I remember, .max PGStar statements .max parameter by default is 5,000, if I'm not mistaken. It can be tuned to 10,000 or 100. It means that we don't register all queries, so we probably see only the tip of the iceberg. And QPS can be wrong if we use this approach. If we use calls metric from PGStar statements. When I have doubts, I usually like in most of the cases we have PG Bouncer, so I check PG Bouncer logs, and it reports QPS, like fair number of QPS. But this is like maybe already
Let's-
too deep about it. Right.
Yeah,
this
let's
is throughput.
focus on the things we can measure in Postgres.
Right. This is throughput. Latency, it's query duration. Again, usually it's measured from PGSS statements. Timing. And we why it's important, because we need to understand, for example, if QPS and TPS dropped significantly, maybe it's just a problem with application. Errors on application caused our load dropped. Maybe it's a problem related to CPU 100%. All CPUs are 100%. We have saturation or disk saturation on Postgres. That's why we process fewer TPS. And latency, of course, very important. Like latency is monitoring average latency. It's very important. And I see in many cases we don't have it in monitoring. These two metrics are it's our general health of our database. Should be always go first. We have problem. Let's check TPS, QPS, and latency, average duration of queries. So next, very, 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 very important, and I don't also see more than 50 systems are not good with this. It's connection monitoring. My ideal is just one single chart, and we have stacked graph of connections, active, idle transaction, idle, fourth, I don't remember. So, but these three already tell everything, right? So active, we process something. If active goes above number of CPU, it's already bad sign. So if you have 12 cores and we see active 20, well, probably already too much work to do for this server, and probably we have already huge degradation in performance. It's not always so, but in many cases so. Idles and idle connections, idle transaction connections, also very important, especially before Postgres 13 or 14, where
I think
optimization
14.
14, right. So I saw sometimes people say, okay, we have a couple of thousand more idle connections, don't worry, they are idle, but overhead is big. And I think Andres Freud had a very good couple of posts. Also, we should provide links, right?
I think he did a lot of the work in 14. I think he was, yeah.
Mm-hmm. It was related not to memory consumption, as I remember, but how work with snapshots is organized. So, usually people think a couple of thousand connections give us a lot of memory overhead. No, it's more about how work with snapshots is organized. But what I like about stack graphs is that we can quickly understand the total as well, right?
Yeah.
And sometimes people split to multiple charts, multiple graphs. It's also fine, but I like to see connection and overview in one place. So, and of course, I don't in transaction sessions or connections. Connection sessions is the same basically. So you connected, you have session. This is your connection session. It's the same in this context. They are very dangerous sometimes, because if application started transaction and went to talk to some external API, for example, or to do some other work, it can be very dangerous. So we should also understand we should have some threshold and not allow system to go above it.
So yeah,
Right.
so at this point, I guess we're talking about long transactions.
No. Well, sometimes it's quite. Sometimes these things correlate, but not always, because
Okay.
we can have, for example, at each moment we have 200 idle in transaction sessions, right? But duration of each transaction is less than 1 second.
Yeah.
It might happen. Very brief transactions, but they do something and keep connections idle. It's also possible. But next item is long transactions actually, and this is actually a big topic as well, because usually long transactions have two dangers. One danger is to lock something and block others. It's one point. Another point is disturb auto-locking work. But in the latter, we should talk about not long transactions, but about X-min horizon. It should be different And I didn't see it never. Like no monitoring distinguishes these two things yet.
Oh, really? So,
Yes. Show me. Maybe. Of course, I didn't see all existing systems. Of course.
Yeah.
But over the last couple of years, observing various systems, like dozens of them.
Should we talk about that then straight away? So the Xmin Horizon being to avoid transaction ID wraparound, which is, there've been some famous blog posts that I can include on that.
Right. Transaction ID wraparound is one danger from Xmin Horizon being stuck in very past, but also accumulating a lot of dead tuples, and then it converts to bloat. Also a problem.
Right. See previous episode.
Right, exactly. We discussed it already. But again, simple graph, what is the maximum age of the longest transaction right now, excluding vacuum, because actually regular vacuum, by the way, it's tricky. A regular vacuum doesn't hold Xmin Horizon. It doesn't block anyone, except with Analyze, it can hold Xmin Horizon. And if the vacuum is working to prevent transaction ID wraparound, it can block others. So in each area, there are interesting ifs, right? If then. So it's quite difficult to build ideal monitoring, of course. But anyway, I want to have a graph. Do we understand the maximum age of transaction right now?
Yeah. And when are you worried? What kind of number are you worried about there?
Right. In OLTP systems, and by the way, we forgot to mention that we again discuss OLTP systems, monitoring for them, right? Because for analytical systems, things are different. For OLTP, I would like to have everything below, ideally under 1 second. Mm-hmm. Again, it's related to human perception, which is we can distinguish 200 milliseconds roughly. So 1 second feels slow. But of course, sometimes we need slightly longer transactions, a few seconds. But transaction 1 minute, it's already if it can block someone else, it's already a problem. We should split it to batches. Great. But we discussed it briefly last time. If you create an index, unfortunately, you hold the Xmin Horizon, and of course, if your table is big, you need to spend sometimes an hour or maybe even more to build an index, and that's why partitioning is needed again to have this time sane. Good.
So next, I was going to say we're about halfway through our nearly halfway through our dashboard.
Good. So next thing is the ratio of errors. It can measured. We already discussed this exact. From PGStar database, exact commit, exact rollback, how many transactions are committed, how many transactions are cancelled, and we can have a ratio to understand the percentage of successful transactions. And it's interesting, sometimes I see system produces 50%, only 50%, or even fewer successful transactions. But this developers say this is intentional. This is by design, and it triggers interesting questions. What negative consequences can be if application uses rollback too often? It's a separate topic.
The main reason you want this ratio is to see if it changes from your baseline. So if you've got normally a very high ratio, you just want to tell
99%, and suddenly we have 70%. Obviously, it means we have a spike of errors. So we need to go to logs probably and understand which errors. Or if you use extension called log errors, you can have counters right inside database, so you can select aggregated by error type. So next thing is transaction ID wraparound. Separate metric. Here people always, not always, in 90% of cases people forget about multi-exact ID wraparound. They just don't check it. It's less like it's more exotic. Like transaction ID wraparound is exotic, but when it happens, it's a big disaster. But multi-exec ID wraparound, it's even more. It's even like very very rare, very unusual.
Is this the thing that you mentioned in the GitLab blog post about subtransactions?
Briefly.
Yeah.
Yes, briefly. There is connection to it. Yes, because if we use select for share and sometimes select for update, we might have quickly increasing multi-exec IDs and risks of. Well, if we use foreign keys, we just use foreign keys. We have multi-exec IDs. That's it.
Of course. So, are we talking about two graphs here then? One for like, what do we actually need for our dashboard?
It can be one, but just the idea is we should not forget about this second ID, and it also can be like it can be wrapped around. It has the same risk, so we should monitor both risks and alert when it's already above threshold and so on. Okay, then the health of replication. Again, like for this dashboard, we need only brief analysis. Like, do we have at least one standby which is lagging, physical or logical? We should define our thresholds and observe. That's it. Like if we see a spike or a lag, it's also a problem. You can get out of disk space event or something, not good. Then a few things only left. By the way, I realized in this list, we will provide this list, as I've said.
Yeah.
We don't have vacuum behavior, auto vacuum behavior, and we don't have checkpointer and BG writer behavior. We have it in our systems, we have it on dashboard 2. But I think we probably should move it to dashboard 1 as well, because these two big components of Postgres, vacuuming and checkpointing, right? So we should have it here. So
before you move on this one, I see you also had unused replication slots, which I thought was really interesting. I've heard of some issues where, like if you've got a static number of those, if it decreases, if something ends up using one of those replication slots that you weren't expecting, that could be sign of a problem as well, right?
The problem is that, like, right, so we don't have lag per se here, but if slot is unused, it's accumulating walls, so it's easy to be out of disk space soon.
Yeah.
So unused slots are dangerous, definitely. But everything can be here combined on one or a couple of graphs. So, but as I've said, we want to keep this dashboard quite small so we can quickly review everything.
Yep.
And then, like after replication, I'd like to talk about lags related to archiving. And this is very often people don't have it, or very often again. They don't monitor the lag, like how many walls are not yet archived. Why is this important? If you try to stop Postgres, restart or just stop, and it has a lot of unarchived walls, like when we shut down Postgres, there is so-called implicit shutdown checkpoint. And the same way, Postgres tries to archive them all. So it runs archive command of all pending walls, and can take hours. If we accumulated thousands of walls, it happens. You wait.
And it's not just if you want to upgrade or something. It could also be if there's a crash, right? It's how long is it going to take you to recover?
Well, recovery is different. If it crashed, it will recover quite soon. It's just redo what's needed, and that's it. I'm talking about like intentional restart or shutdown. For example, if Patroni wants to perform switchover or failover due to some reasons, it tries to shut down the primary until some version not long ago, because I told Kukushkin about it and it was a surprise because we had it on production in some system. So Patroni failed to perform failover because a lot of walls were pending to be archived. And
Wow.
Kukushkin fixed it. in recent versions of Patroni. Upgrade. It's quite new thing, quite new bug fix. Well, it's not bug fix. It's like an improvement. Patroni doesn't wait and like tries to perform failover. There is a trade-off because what to do with these walls, right? I don't remember details there because if we don't archive walls, it disturbs our DR strategy, disaster recovery strategy.
Yeah.
Right. We need to keep backups in good shape. So this is an interesting question as well. But anyway, monitoring should have this number of pending walls, or also maybe the rate of archiving. How many walls we archive per second, for example. It's very, very interesting metric as well to understand.
You've got that next on the list.
Okay. Yeah, okay. Wall generation rates. As I recently learned, if you have few walls per second, probably you won't be able to use a logical replication because a wall sender will saturate single CPU core. And finally, locks and deadlocks. Maybe they should not go together because like they are different things, right? And locks, of course, sometimes people draw both exclusive and share locks. There are many kinds of locks. Here we talk about heavy locks, not lightweight locks or latches and so on. Heavy locks. So we are locking rows and locking tables. And here, sometimes people try to draw everything, but we should focus on maybe only on exclusive locks, which can be a reason for blocking others. First reason. Well, it's also like there are many problems there. Like this chart alone can be difficult to implement properly, but anyway, we want to have something. I just saw sometimes application engineers they say, oh, we had a spike of locking, like spike of locks. You look at it, oh, you had spike of share locks. It's okay because you had some deployment. It's normal. It's not a problem. So this chart is also like interesting. What should be there? And deadlocks, of course, we want to understand how many deadlocks. So many other things are missing here, but I'm not a big fan of combining physical and this logical. Like, for example, in Datadog, if you check database monitoring, you will see CPU combined with TPS. It's a mix of everything. It's not right.
Yeah.
Host stats, I would like to see separately from database stats. What do you think?
Interesting. Well, I think in the early days, I've seen a lot of teams get really far looking at application stats and then adding some database things into it. They don't have some of these like real scaling issues. I guess I think a lot of people implement monitoring after a big issue, after a big outage. They do. They think, oh, maybe we do need it now. So probably people put this in general a little bit too late. But yeah, I can see an argument for keeping it where the application monitoring is, especially from the query performance point of view, at least especially from the performance monitoring, maybe not so much from the troubleshooting we've had an outage perspective.
Right. Well. Again, we just didn't discuss here query analysis. It's another half an hour at least. It's very interesting, very deep topic. But I also forgot to mention that we took PGWatch 2 from Cybertech. And I remember when we first reviewed it didn't feel well. Like strange dashboards to us, like very like you explained. Oh, why not to add this? Why not to add that? But the fact that it's open source, good components like Grafana and so on, like it can use Postgres and Timescale. So Vitaly from my team implemented initially the set of dashboards following this philosophy. So dashboard number 1 is for quick and very shallow troubleshooting, understanding which areas need further analysis. Dashboard number 2, more interesting things for DBA. Dashboard number 3 is query analysis, and it's available. So it's open source available. And recently, another contributor helped us to support timescale version. So Postgres and timescale can be used as storage. And I I encourage everyone to consider it as a secondary monitoring. Probably you already have something like Datadog, right? Which is like usually, or anything else.
Or
which usually,
APM, yeah.
Organization already adopted some tool for everything, not for databases, not for Postgres. And of course, it's worth having it everywhere because it's like unified solution. But it's missing a lot of things, and I hope I convinced our listeners today that there are many things that should be present there. So PagerWatch 2 can be added like a secondary monitoring, very gentle, without big observer effect, and it can provide a lot of insights for database experts, and actually not only experts. This TPS QPS plus latency, it's this throughput plus latency, it's alone already something very good, which many systems missing.
Yeah, absolutely. So I guess if you don't have some of these things, maybe look into how much work it would be to add them, and hopefully it would save you or make it a lot easier next time you have a big issue to spot what's going wrong.
Right, and if you develop your tool in-house, or you are a developer of monitoring, this list, it's a product of community work, like several months of work. I discussed it on Twitter, during our sessions in Russian community and so on. This list was I think it's very, very useful for checklist for everyone who wants to develop great Postgres monitoring. So please use it as a reference, what should be added.
Awesome.
I think it will be useful, right? Probably one day we will discuss query monitoring as well. I have something to say about it too, right?
Definitely, part 2 coming. Brilliant. Well, thanks everyone for joining us again. I really appreciate it. Let us know if there's anything else you want us to make sure we covered, or anything you think we missed. It'd be very helpful. And check out the show notes I'll include links to all the tools we mentioned, or various things as well, including this list. Yeah,
and thank you again for feedback. Feedback is a very important thing to have. Twitter and other places. And please subscribe, like, and share everywhere in your social networks and groups where you discuss engineering and databases and so on.
Wonderful.
Okay.
Well, thank you, Nikolai. Good to see you, and
thank you,
speak to you next week.
Till next time. Bye-bye.
Cheers. Bye now.